go ahead and walk you through these few questions that you've had. Um, First one says find the focus, directrix, focal diameter, vertex, and the axis of symmetry for the parabola. 36.4y equals x squared. Looks like you've got like the general idea here. As I mean, you're getting the directrix right, and the focal diameter, all that kind of stuff. All that stuff's good. When it's of this form, okay, so that is a parabola that is opening upward, like I've drawn down here. Okay, and it's of the form then, so all parabolas that open upward are going to be of this form here. Okay, and that's the conic section form. We can, and it's really, and that's centered at 0, 0. There is, which we'll use here in a moment. I get it mixed up with A. Okay, so it'd be K. Y minus K equals x minus h squared, where h comma k is the center. That's a better format because that's going to allow you to move it left and right, up and down, depending on what kind of parabola it is. So just using, so if it's centered at 0, or not centered at 0, but it's on the y-axis here, like my picture is showing down here, then it's going to be of this form, 4py equals x squared. So then what we have to do is we have to figure out, well, what is p? So, and you've done this correctly. You've taken, well, that right there, that 4p matches with the 36.4. So we set those equal each other, and we get p to be 9.1. Okay, well, what does that tell us? Well, that's the location of the focus. The focus is always at 0, comma p. So 0, comma 9.1. The directrix then is always in the opposite direction of the vertex, p units away. So if that's the vertex, then that distance right there is 9.1, and that would then give us the directrix being the line y equals negative 9.1. Okay, so you just got, you basically put your focus down here where it should be on the internal portion of the parabola, or inside the parabola. The next one here, so I drew the arch. The arch, it says it's a, there's two ways of doing this, and I like the initial way, my first way, because it's really what we did earlier in the course. And if you're just creative with, I don't want to say creative, but knowledgeable about your order of operations, all that kind of stuff, you can get the form to match what they're looking for here. But I'll show you how to do it both ways. I just drew the picture here. It says the parabola has a span of 84 feet. So if this orange here is the ground, that distance is 84. The height of the parabola, the maximum height, is at 6 feet. So that's the vertex, 0, 6. When it says span, so that's telling me at this point right here, that point right there is 0, 0. And the span then, that distance right there is going to be 42 feet. So it gets me this extra point right here of 42, comma 0, which is going to be pretty critical as we go through this question. Now, the way I like to do it is using this formula. Okay, that formula is the vertex form for parabola that we learned earlier in the course. So all I've done is, in order to find the standard form that they're asking for, is I just fill in this information that I know from the parabola here. Okay, so the vertex is h, comma k. So what I've done here, h obviously is 0. K in this case is going to be that 6, so I plug that in. So then y equals a times x minus 0 squared plus 6. So that ends up giving me this. Okay, obviously x minus 0 is just x, square it, I get that, plus 6. Now that's the general form, but now I need to figure out what this a is. This a is what we call a scalar multiplier. So how do I find that? Well, I need another point on the parabola to do that. Here's the other point, and that's why they tell you what the span is. That other point is going to allow me to do that. And you can do that at any point. I moved the 6 over. You could do this without moving that 6 over first. But I move that 6 over in this step, and then, okay, well, if y is 0 and x is 42, so I plug in y to be 0 and x to be 42, go ahead then and solve for a. So I get negative 6 is equal to 42 squared times a. So that gives me 1764a is equal to negative 6. Solve for a, and a ends up being that thing there. So now if I go back up to this general formula right there, where I had y, x, and my plus 6, okay, and it was this x was squared, and plug in the a that I know, well, a is negative 1 over 294, I get this equation there, okay? I don't know if xyz would accept that because it is the same as that. It's just a different variable being isolated. But if they don't accept it and I need x squared to be solved for, well, I just come down here and I solve for x squared. So I'm going to subtract 6 from both sides, and that's where I get this right here. And that gives me negative y minus 6 equals negative 1 over 294x squared. Now to isolate x squared, I'm just going to multiply both sides by negative 294, and it gives me that there, which matches exactly to what they were looking for. Okay. Now, the alternative way of doing that is, like I said up here when we did this question, that we were going to potentially, we're going to want to use this formula here to address the correct way of getting this parabola in this standard form that they're looking for. So using this, x minus h squared equals 4p y minus k, where that's still h comma k is still the center. Okay, and it may seem kind of trivial for the h because the center is it's on the y axis, so the h is going to be 0. So we plug that 0 in, so it just gives me this x squared eventually. And then I got 4p times the quantity y minus 6. Well, why is it y minus 6? Well, that's because the vertex was moved up 6 units. So y minus the k value of 6 gives me that. Okay, and that's kind of, I think, this, without using that, people get kind of struggling. If they're just trying to use x squared is equal to 4py to get the parabola, they struggle because, well, where does that 6 come into play? Why do they tell me that vertex? How do I get to move up? And that's how you get to move up, using this version of the formula, which is more detailed. This here is if it were centered at 0, 0, but the vertex is not centered at 0, 0. So going ahead then and, simplifying that, just give me x squared. Now this, because it does open downward, okay, and this is kind of, I kind of neglected this here. That's actually going to be a negative 4p, and you see here I did put the negative there because it's opening downward. So now I've got to solve for p. Well, how do I solve for p? I got 3 variables. I got my x, I got my p, I got my y. Well, how do I solve for p? Well, I'm going to use, again, that value or that ordered pair of 42, 0. Those are x's and y's that I know should be true for this equation. So I plug in the 42 for the x. I plug in the 0 for the y. Go ahead and evaluate. Once I evaluate, I get 1764 is equal to 24p. And then go ahead and solve for p. It gives me 73.5. So that's where, so p, obviously 0 comma p is where the vertex should be, and then obviously then where the directrix should be. Sorry, let me rephrase that. The p-value helps you find where that directrix and focus should be, because it is p units away from the vertex. So we would go p units that direction and p units that direction to find the focus and the directrix if we needed it. They're not asking for those, but if we needed those. So now I'm going to go back up to this version here where I knew everything but what p was, and I'll plug p back in. And when I plug p of 73.5 in there, it gets me that version right there, x squared equals negative 294 times y minus 6, which you can see was the same as doing it the alternative way. The next question is very similar. Again, I think that the issue is, again, this is similar to the last video I made for you. The terminology they use can be problematic sometimes, and I think here one that that some people can struggle with is that they say it's 9 feet deep at its center. This is the image that they're asking for. So this would actually be, so I've got my axes here. Here's my y-axis. Here's my x-axis. My parabola is going to be this here, okay? We're really not, because it is a satellite dish, it does not go on forever. So that would really be my parabola. And it's saying that it's at a depth of 9 feet at its center. So that's where I'm getting this distance right here of 9. And that would then give me my vertex to be at 0, -9. It says it has a span or an opening across the dish of 144 feet. So you can see that here, which would then generate that point right there of 72,0. So that's an X and that's a Y. Obviously, this is your H and your K. So then addressing it using this formula, basically going through and just plugging in H and K. So H was 0, K is -9. So I get that. This formula, I need to know what the scalar multiplier of A out front is. So I go through and I just start evaluating. Okay, so it's going to give me Y equals A times X squared minus 9. I go ahead then and add 9 to both sides in this line. Now I know, okay, I've got to find what A is. So in this line, that's where I'm taking the point right here, 72, 0, and plugging it in for Y being 0 and X being 72. Evaluate, and I end up with A is equal to 1 over 576. Plugging that back in then to this to get my parabola, it's going to look like that. So that's solving for Y, and my parabola is solved for Y. But then if X, Y, Z's require me to have my parabola solved for X squared, then I just take this thing here and I solve for X squared. So I add 9 to both sides like I did here. And I'm going to multiply both sides by 576 to isolate X squared, and there's that parabola. Okay. Now, likewise, if you're using this formula here, remember H, K is your center. Now, our center was at 0, -9. This is where some people can make mistakes. I get X minus 0 squared equals 4P. Now it's Y minus K. So Y minus -9 turns into Y plus 9. So this ultimately gives me X squared equals 4P times quantity Y plus 9. Again, now at this point here, I'm using that ordered pair, substituting for X and Y. Go ahead and solve then for P. So simplifies to that. Goes down even further to that. Once I square 72, it gives me P to be 144. Okay. So P is 144. And then if P is 144, going back then to the formula X minus H squared is equal to 4P Y minus K. I'm going to plug in 144 for that P. I'm going to plug in my center of 0, -9 for H and K. And when I do that, it all evaluates back out to x squared equals 576 times the quantity y plus 9, which is exactly what we found there as well. Okay, so those two techniques match up. The next thing that I guess to ask you, how far above the vertex should the receiver be placed? So the receiver is always located at the focus. So basically what happens, just to give you some physics about parabolas, and I don't know watching the videos if they talk about this or not, but whenever light and or sound waves or just anything that moves in a wave form hits a parabola, this is why like light or flashlight, if you look at a flashlight, the cone in a flashlight where the light is actually at the focus, and they're convex parabolas. Okay, so basically what happens is that when light comes into and it hits the reflective edge of a satellite dish or, like I said, a flashlight, what happens is that then bounces directly to the focus. No matter where that light hits on this curve, it all gets back to the focus. Okay, so in regards to like parabolic microphones, parabolic satellite dishes, and this kind of stuff, the waves are moving this direction, and they get focused onto that receiver, which then takes whatever data was encoded inside those waves, microwaves, sound waves, whatever it may be, gets sent to that receiver and then decoded that way. Okay, so they're all focused on that. The way a flashlight works is that the photons originate there at the light, and then they go this direction, and they bounce off the parabolic reflective surface, and then they are sent out in a concentrated beam. Sorry, my daughter is calling me. But hopefully that helps with that question. And I'll answer this phone call, and I'll be back to answer this last one. All right, so the next question says, write an equation of the hyperbola centered at the origin with length of the horizontal transverse axis 12, and the curve passes through the point 9, -5. So I went ahead and wrote down the hyperbola general formula here: x minus h squared over a squared minus y minus k squared over b squared. For a hyperbola opening left and right. Says the transverse axes, that's the axes that connects the vertices of the hyperbola. So that's a vertex of the hyperbola, that's a vertex of the hyperbola. It says it's 12, okay?